All right, the bus. A bus is traveling at a constant speed along a section of road that's inclined at an angle of 6 degrees. And notice that that's 6.2 meters per second, okay? That's just how they write it, okay? Now, okay, I'm going to give you a clue. You want to draw arrows that emanate from this thing, right? That means that they're going to go like that, only that's not one of the forces, right? Okay. Draw arrows that emanate from that, okay? And I'm going to give you a clue. There's 4 arrows in the mark scheme, okay? 2 of the arrows are parallel to the plane, okay? They're this way or this way. And one of the arrows is perpendicular to the plane, and one of the arrows is straight down, okay? Label them with what they are. And be careful. The one that is the force of gravity, call it the force of gravity. Don't just say gravity, okay? Or you can call it the weight, okay? State the value of the rate change in momentum of the bus. Well, momentum is mv. So ask yourself, is the velocity changing? IQ on the line, right? Is it changing? If it's not, well, anyway. Remember, state is just, you just say what it is. You don't need to justify it. All right, let's take a look at this page here. Okay, so this is just an efficiency problem. It's adorable, right? So they want the input power. This is the power output, right? So remember, efficiency is power output over power input, okay? So use 0.35 as your efficiency. Don't use 35, right? 70 kilowatts, that's your output. Solve for your input, right? All right. Then the next one says, the mass of the bus is blank. Determine, so that's, by the way, 8,500 kilograms, right? Determine the rate increase of gravitational. So this is going to be a power, right? So power is, and I would use force times velocity. This is what I did, right? And then the force of gravity that you're opposing, that's parallel to you on that plane, is going to be mg sine theta, okay? And then the velocity is our 6.2 meters per second, yeah? And that'll give you something. It'll be less than the power output of the bus, I'll tell you that. Somewhere between 50 and 60 kilowatts, okay, will be your power output, right? Now, then it says here, use your answer in C and the data in B. The data in B, especially that we're going to use, is this, right? Okay, to estimate the magnitude of the resistive forces acting on the bus, okay? So let's imagine, so this is 70 kilowatts is the power output, right? Okay. Let's imagine that we're doing work against friction to the tune of 50 kilowatts. That's just 50,000 watts, right? Do you see that there's 70 kilowatts being put out? There's 50 kilowatts actually going into lifting it up the hill. Doesn't that leave 20 kilowatts left over, right? And what's that doing? Well, that's just working against the resistive forces, right? So find the difference between 70 kilowatts and your answer here, which is not 50, by the way, okay? Subtract those two, right? So power output minus the answer to C, right? Whatever that answer is, right? That's your power, and then that's being used to operate against the resistive forces. Set that equal to force times velocity, and again, you have the velocity is 6.2, okay? Yeah? Yeah. All right. I think that's it.